Okay, so today what we're going to be working on is adding and subtracting polynomials. So I would like you to do the try this. The try this says identify the coefficients, variables, and exponents. So you have two problems here. I would like you to put me on pause and just identify which is the coefficient, which is the variable, which is the exponent. And then come back and check your answers. Okay, so for number one, which says 8x to the third power. So the coefficient, remember, is the number that's in front of the variable. So for number one, 8 is the coefficient. The variable is your letter. So in this case, x, I'm just going to underline it here, x is your variable. And the 3, right up here, is your exponent. All right, so number 2, your coefficient is 16. We actually have two variables. The variables are x and y. Now, it looks like we only have one exponent, the 2. But remember, when you have a variable or even a number and there's no exponent written, there's really an exponent of a 1 there. So always remember that's an exponent of a 1 when there's no exponent written. So those are your exponents. So we have an exponent of 2 and an exponent of a 1. All right, so let's take a look at what like terms are. So hopefully you will remember that like terms are when you have the same variable. So let's write down same variable with the same exponent. All right, so I would like you to look at the examples below. And the examples below say identify the like terms. So I just want you to list what are the like terms here. So I have here x squared, 4y, 2x squared, and 3y. So if I take a look at this first one, x squared, I'm looking for another x with a square, and only that. Only an x with a square, no other variable with it. So I notice this right here, 2x squares, right? It has an x with a square. Now remember, when there's no number in front of the variable, there's really a 1. So that's a coefficient of a 1 there. So a pair of like terms would be 1x squared. You don't have to write the 1 if you don't want. And 2x squared. Those are like terms. Another pair of like terms would be the 4y. Remember, that's y to the first. And 3y to the first. They both have y to the first power as their variable. So let's write that down. 4y. Remember, that's 4y to the first. And 3y. Those are like terms. All right, let's take a look at number 2. So I have 3x squared y to the third, 2y to the third, 5x to the fifth, y to the third, 8x to the fifth, and 10x squared y to the third. All right, let's start with this one right here. I have an x squared y to the third. So I'm looking for something else that has a x to the second and a y to the third. I'm looking for that. So I notice right down here, x squared y to the third. So that means those are like terms. So 3x squared y to the third and 10x squared y to the third. Yes, they have more than one variable, but they are the same variables with the same exact exponent. All right, so let's see what else we have. I have a y to the third here. So I'm looking for another y to the third, and I see a y to the third here. Remember, that's a coefficient of a 1 in front if there's no number written in the front of the variable. So we have 2y to the third and y to the third. So it's 2y to the third and y to the third. Remember, there's really a 1. You don't have to write the 1, but remember there really is a coefficient of a 1 there. All right, and what else do we have here? We have 5x to the fifth and 8x to the fifth. They both have an x to the fifth power. So those are like terms. So that would be 5x to the fifth and 8x to the fifth. All right, so let's get down to adding our polynomials here. I'm just going to push everything up here. All right, so when we add polynomials, all you do is combine like terms. So let's write that rule down. So we're going to combine like terms. You can get rid of the parentheses if you want. So if you want to write that down, you can get rid of parentheses. Okay? All right, so we're looking for like terms. Remember, when you combine like terms, you're adding or subtracting the coefficients, whatever operation, and you keep the variable and the exponent the same. So let's take a look at the first one. I'm going to get rid of the parentheses. So I have an x to the second. Remember, that's really 1x to the second plus 3x minus 8 plus 5x to the second plus 4x minus 6. I'm looking for like terms here. All right, so I see an x to the second and a positive 5x to the second. Remember, the sign in front, so this has a plus, goes with the term. So it's a positive 1x to the second and a positive 5x to the second. So you add the coefficient. So we have 1 plus 5. So that's 6. So it'll be 6x to the second. You don't add the exponents. Everything, the variable and the exponent stay the same. Okay? All right, so let's look for another pair of like terms. I see positive 3x. I'm looking for another x. And I see positive 4x. Right? They're both x to the first power. So I add the coefficients. So I have positive 3, positive 4. So it's 3 plus 4 is 7. So I have plus 7, and you keep the x. Remember, we don't do anything to the exponents. So they both have an x to the first. It stays x to the first. All right, and then we have just an integer here. Negative 8 and negative 6. So we add them. Negative 8 minus 6. Negative 8, you can use your calculator. Negative 8 minus 6 is negative 14. So my final answer is 6x to the second plus 7x minus 14. All right, let's take a look at number 2. All right, so again, I'm going to get rid of the parentheses. So I have 2x to the third minus 4xy minus 5y to the second plus 6y to the second plus 3xy. And I'm sorry, I have to squeeze this in here. Minus 6x to the third. Okay, so let's look for like terms here. So I'm going to start off with, I have an x to the third. I'm looking for another x to the third. And I see it down here, and that's a negative 6x to the third. Same variable, same exponent. All right, so I have a positive 2 minus 6. So what's 2 minus 6? 2 minus 6 is negative 4. So it'll be negative 4x to the third. All right, next. I have a 4xy here, negative 4, sorry, xy here. I'm looking for another xy. And I see there's an xy right here. So they're like terms. It's positive 3xy. So it's let me box this off. Negative 4xy and positive 3xy. Those are like terms. So we have negative 4 plus 3. That's negative 1. So it would be negative 1xy. That's a 1 here, not a 7. If you just want to write negative xy, that's the same thing. That's up to you if you want. Okay? All right, and let's see what else we have here. I see that I have a y to the second, and here's another y to the second. So that means those are like terms. That's a negative in there. Negative 5 y to the second and positive 6 y to the second. So it's negative 5 plus 6 is positive 1. So that would be 1, positive 1. You could put the 1. You don't have to put the 1. Positive 1 y to the second. Okay? So just recall and be aware that when you look in textbooks, these ones actually would not be written there. It would just be written like this as the final answer. So always just be aware of other ways to represent the answer. Negative 4x to the third minus xy plus y to the second. Okay? All right, so let's take a look at subtracting. Just going to get rid of this here. All right, so when we subtract polynomials, you have to distribute the negative. So let's write that down. Distribute the negative. And when you do this, you're going to remove the parentheses. And then all you do is combine like terms, what we just did up top. Okay, so I'll show you what I mean and why this is true. So remember what I said, when you have a variable that there's really, if you have a variable and there's no number in front of the variable, there's really a 1 there. So when I have these parentheses here, there's really a 1 in front of the parentheses. So this here, since there's a minus, there's really a negative 1 here. So really what I'm doing is this. If I have a 1 here and a negative 1 here, I'm really distributing. So when I distribute a positive 1, everything will stay the same. So this will remain x to the third plus 5x squared minus 4x plus 1. Now, when I distribute the negative 1 here, because that's minus a 1 parentheses, we distribute. So negative 1 times 4x to the third is negative 4x to the third. Negative 1 times negative 8x squared is positive 8x squared, right? Negative times a negative is a positive. Negative 1 times negative 6x is positive 6x. And negative 1 times negative 9 would be positive 9. So remember, when you distribute a negative 1 or any negative, it's going to change all the signs. That's where you learn same, change, change, if they taught you that in the middle school someplace. That's where it comes from. Distributing the 1, we keep everything the same. You would change this to a positive, and then you're really distributing the negative, which really just changes all the signs. All right, and now we're just back to combining like terms. So I have a positive x to the third here. Sorry. So I have a positive x to the third here, and a negative 4x to the third. So remember, there's really a 1 in front of the x to the third over here. So that's 1 minus 4 is negative 3. So that would be negative 3x to the third. I have here positive 5x squared and positive 8x squared. So that would be 13x squared, right? 5 plus 3 is 13, so that's plus 13x squared. And then I have negative 4x and a positive 6x. So negative 4 plus 6 is positive 2x. And then I have the 1 and the 9 there. So let me use this. We have the 1 and the 9. So 1 plus 9 is 10. So that would be my final answer. All right, so let's take a look at the last one. All right, so the last, I'm just going to move everything up. Okay, so it says subtract 6x to the 5th minus 3y to the 3rd z plus 4x squared y minus 3 from 5x to the 3rd z minus 11x to the 5th plus 9. So when you have a subtract and a from, your from always comes first. So I want you to set it up as a subtraction of polynomials. So your from comes first. Your subtract comes second. All right, so in parentheses, we're going to put 5y to the 3rd z minus 11x to the 5th plus 9. Subtract, and then we have our second parentheses, 6x to the 5th minus 3y to the 3rd z plus 4x squared y minus 3. Okay, and the same thing, we're going to distribute the 1 here, which will keep everything the same. So it's 5y to the 3rd z minus 11x to the 5th plus 9. Distribute the negative. It's going to change all the signs. So it'll be minus 6x to the 5th plus 3y to the 3rd z minus 4x squared y, and then I'll have a plus 3 there. And now we're going to combine all the like terms. So I have here 5y to the 3rd z. So I'm looking y to the 3rd z right here. Add the coefficients. So we have 5 plus 3 is 8. So it's 8y to the 3rd z. I have here a negative 11x to the 5th. I'm looking for an x to the 5th. So I see one right here. So negative 11 minus 6 is negative 17x to the 5th. I see that I have 3 terms left, right? I have a positive 9, a positive 3, and then this guy here. So when I add the 9 and the 3, because those are like terms, they're just integers, 9 plus 3 is 12. And now what do I do with this guy here that has no matchup? Well, you just kind of tag him along, and you can put him right at the end, just like that. Okay, so that's it, and I hope you have a good rest of the day, night. I'll see you guys, or talk to you guys tomorrow.